In this video, now we are going to discuss exercise 8.2. It is all about the sample space diagrams. These are also known as probability space diagrams. And the tree diagrams are also one of the forms of sample space diagrams or the probability space diagrams. Like this, for example, a coin toss. A coin is tossed and either you get a head or you get a tail. The probability of getting a head is 1 by 2 and the probability of getting a tail is again 1 by 2. And if I give you an example of a dice roll, its tree diagram is going to be either you are going to get a 1 or 2 or 3 or 4 or 5 or 6. So the probabilities of all of them, if you assume that the coin is a fair coin, is 1 by 6, 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 and 1 by 6. So that is the tree diagram. That is one of the forms of the probability space or the sample space diagram. Okay, now it is question number 1. An unbiased coin is thrown twice, and the outcome for each is recorded as H for heads and T for tails. A sample space diagram can be drawn as shown. The first throw is this, either getting a head or a tail, and the second throw is like this, also getting a head or a tail. Copy and complete the diagram. Okay, we need to complete the diagram. TH is an example that T is for the first throw and this H is for the second throw. For this uh, box of the intersection of this matrix, H is for the first throw and this H is for the second throw. Okay, for this box of the matrix, from the first row we are going to have head, and from the second we are going to get a tail, and this is to get a tail from both of them, tail from the first and then tail from the second. So this is how we had to complete the sample space diagram. Okay, let me erase some extra things for a clarity. Okay, okay. Find the probability that the coins show the same face. The same face is either HH or TT. So these are two chances. Same face. Two chances out of four. That simplifies to 1 by 2. Okay, for the second part, the coins both show heads. Both head. That is only one chance out of four total chances. So the probability is 1 by 4. Okay, now part 3. There is at least one head. At least one head means either it is one head or even two heads. So for one head, we have got either this one, tail head, or this one, head tail. So there are two chances for this. And For both the heads, we have got one chance. So 2 plus 1, that is 3 out of total 4 chances. That contains at least one head. And for part 4, there are no heads. So this is the only chance where we do not have any head. So probability of no heads is going to be 1 out of 4. So that completes question number 1. Now we proceed to question number 2. Two unbiased dice are thrown and the product of two numbers is recorded. Product of two numbers. It means, for example, if the first dice that was showing up to, and for the second dice that was number 5. So the product is going to be 2 times 5, that is 10. 10 is what is going to be recorded. Okay. Draw a suitable sample space diagrams to show all possible outcomes. Okay. For that, we need to have, let me use this one. And then I draw lines like this one, this one, and then this one. Similarly, one for this, this. Okay, that actually means what? One would also be like this. Let it be the first dice throw, and this is going to be the second one over here. The possibilities are obviously 1, 2, 3, 4, 5, and 6 for the first one, and then 1, 2, 3, 4, 5, and 6 from the second dice. And we need to record their product. Okay, it is going to be like if you have got 1 from the first dice and 1 from the second, the product is going to be 1, 2 from the first and 1 from the second. It is going to be 2. Similarly, 3 times 1, 3, 4 times 1, that is 4. This is 5, and then this is 6. Now for the second row, 1 from the first dice and 2 from the second. So 1 times 2, that is 2. 2 from the first and 2 from the second. It is going to give us 4. 3 from first and 2 from second. 3 twos are 6. Then 4 twos are 8. 5 twos are 10. And 6 twos are 12. Then 1 from the first and 3 from the second. So 1 times 3 is 3. 2 from first, 3 from second. 2 threes are 6. Then 3 and 3. 9, and 4 times 3, 12, 5 times 3, 15, and 18. Then 1 from the first and 4 from the second. This is 4. Similarly, 2 from first and 4 from second. 2 fours are 8. Then 3 fours are 12. 3. Then 4 times 4, 16. 5 times 4, 20. And then 6 times 4, 24. And now for this, 1 from the first and 5 from the second. 1 times 5, 5. 2 fives are 10. 3 times 5, 15. 4 fives are 20. 5 fives are 25. And then 6 fives are 30. Then 1 times 6 is 6, 12, 18, 24. 5 times 6, 30. And 6 6 are 36. Okay, this is the sample space diagram of part A. Okay, now for part B. Part 1. Find the probability that the product is 1. That product is 1. So from the whole of this table, you can see this is only 1 times 1. So its probability is going to be 1 by 36. Then for part 2, the product is 7. From this whole table, you see that there is not a single time that the product is 7. So probability of product getting 7 is 0 by 36. That is 0. Okay, now the third part. The product is less than or equal to 4. 1, 2, 3. 3 times it is 4. Then for lesser than 4, 3, 2, and then 1. So how many are these? 1, 2, 3, 4, 5, 6, 7, 8. So in third part, these are 8 by 36. What's that? That's the product is less than or equal to 4. So simplifying it, you can have 4 twos are and 4 nines are. So 2 by 9. That's okay. Then part 4, the product is greater than 4. Since 8 times the product was less than or equal to 4, so for product greater than 4, we are having 36 minus 8, that is 28 by 36. So that is the answer. You can simplify it. 4 sevens are 28, 4 nines are. So the answer is 7 by 9. Okay, then I can have part 5. The product is a prime number. Okay. Prime 1, 2, 3, 4, then 5, then 6. Okay. 6 times it is that we are getting a prime number. So 6 by 36. Simplifying it, 6 ones are and 6 6 are. You get 1 by 6. That is the product is a prime number. Okay. Now for the sixth part, the product is a square number. Okay. Which of these numbers are square? Okay. One is a square number. One ones are one. Or square root of one is a whole number, an integer. So one, or you can say that one square is one. A square number is a number whose square root gives you a whole number or an integer, positive integer. So similarly, 4, when you take its square root, you get 2. Then for square root of 9, you get 3. For square root of 16, you get 4. And for square root of 25, you get 5. For square root of 36, we get 6. So all these are square numbers. So let's find and count them. How many are these? 1, 2, 3, 4, 5, then 6, 7, 8, okay. Actually, these two are obviously not the prime numbers. These are not the, these are prime numbers, but these are not the square numbers. So I need to exclude them. Then it is 25 and then 36. So counting them, 1, 2, 3, 4, 5, 6, 7, 8. 8 are the square numbers. So for part 6, probability of the product to be a square number, that is 8 by 36. So 4 twos are 8, 4 nines are. So its probability is 2 by 9. That completes this question. Question number 2. Okay, now it's question number 3. The diagram shows a spinner with 5 equal sectors numbered 1, 2, 4, 6, and 8. This one. And an unbiased tetrahedral dice with faces numbered 3, 5, 7, and 9. Okay. Its back face would be having a number 5. The spinner is spun and the dice is thrown, and the greater of the two numbers is recorded. Okay. If, for example, this is facing up by 7 and this is facing up by 6. So out of 7 and 6, we are going to record 7 only. Okay. This is what is to be done. Similarly, like for example, if we are having 4 from this and 3 from this, so we are going to record 4, not 3, and so on. If both show the same number, then that number is recorded. Okay. Draw a sample space diagram to show the possible outcomes. Okay. We need to do it like that. Let's do it. This is for the spinner. 1, 2, 4, 6, then 8. And then for tetrahedral dice, I need to have, let's suppose, 3, then 5, then it is going to be 7, and then 9. So let me write them down. For the spinner, and I would be writing here for the dice. The numbers for the spinner are 1, 2, 4, 6, and 8. And for the dice are 3, 5, 7, and 9. These numbers. Okay. Now, how do we need to fill them up? Let's see. Uh, when there is 1 and 3 from the dice, the largest is going to be recorded as 3. When spinner is showing 2 and dice is showing 3, we are again going to note the greater one, which is 3. For 4 and 3, we are going to record 4. For 6 and 3, we are going to record 6. And for 8 and 3, it is going to be 8. Then for 1 from the spinner and 5 from the dice, it is going to be 5, 2 and 5. This is 5 again. 4 and 5 will give us 5 again. And for 6 and 5, this time it would be 6. And for 8 and 5, this time it is going to be 8. Then 7 from the dice and 1 from the spinner. We are going to record 7. Then 7 and 2 would result in 7. 7 and 4, 7. 7 and 6, 7. And 7 and 8, it is going to give us 8. And then 9 from the dice and 1 from the spinner. This is going to be 9. 9 and 2, 9. 9 and 4, 9. 9 and 6, which is going to be 9. And 9 and 8, which is going to result 9 to be recorded. Okay, so this is the answer to part A. Draw a sample space diagram to show the possible outcomes. We have drawn that. Okay, now part B. Calculate the probability that the greater number is even. Okay, the greater number is even. We need to see the probability. So let's count the even numbers. For part A, probability that the greater is equal to even. This is going to be 1, 2, 3, 4, 5, 6. So this is going to be 6 by total 20, like 1, 2, 3, 4, 5. 5 are the possibilities for this. 1, 2, 3, 4. 4 are the possibilities for this. So all together, total is going to be 5 times 4. That is 20. So that's why I divided it by 20. So simplifying it, 2 3s are and 2 10s are. 3 by 10. It can also be written as 0.3. Okay, that's the answer to part 1 of part B. Okay, now it is second part. Okay, I'm writing it here. The greater number is odd. Okay, from the total 20, 6 times we were having odd numbers. So that means probability of the greater number to be odd is 1 minus probability of the greater number to be even. So that was 1 minus 6 by 20, which will give us 14 by 20. So simplifying them together, 2 7s are and 2 10s are. So the answer is going to be 7 by 10. Okay, now for part 3, the greater number is a multiple of 3. Okay, multiple of 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So probability that the greater number is multiple of 3, M3. So these are 9 by 20. Okay, now for part number 4, the greater number is prime. Okay, we need to count the prime numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that is also 9 by 20. For part 4, that the probability of the greater number is prime, 9 by 20. Okay, now for part 5, the greater number is more than twice the smaller number. Okay, let's see. When we were having 1 and 3, the greater number was recorded, that was 3. So that is obviously 3 is greater than twice of the smaller number. 3 is greater than even 2. So yes, we are going to record this once. Let me change the marker color. Let it be this one, purple one. Okay, 1. Now if you compare 3 and 2, so 2 times the smaller number is 4. The larger number, which is 3, is not more than twice of this. So I'm not going to count this one, and no more number from this row. What about 5 and 1? You multiply 1 by 2, twice of 1 is 2. So 5 is more than twice of 1. So yes, this is going to be calculated. Then 5 and 2. 2 times 2, that will give me 4. So this 5 is more than 4. That is twice of 2. So this is going to be calculated 3. But 5 and 4, this time 4 times 2 is 8, which is obviously not greater than 5. So I'm not going to calculate this 5 this time, and no more number from this row. Okay, 3, then 7 and 1, 4. Similarly, 7 and 2. This is going to be counted as for the fifth number. 7 and 4. When we will do 4 times 2, again it is going to be 8. So 7 is not more than the twice of 4. So I'm not going to calculate this one. So in this case, 9, 6, then 7. 9 is more than twice of 4. Okay. So this is going to be calculated or counted, and no more number in this row. Since 2 times 6, that will give me 12. And obviously 9 is not greater than 12. And for 9 and 8, twice of 8 is 16. And obviously 9 is not greater than 16. So altogether, I've got these 8 numbers. So probability that the greater number is even greater than twice of the smaller number is 8 out of total 20 times. So which can be simplified to give me 4 twos are and 4 fives are 2 by 5. That's the final answer to this fifth part, and that completes question number 3 as well. Okay, this is question number 4 now. An unbiased cubical dice has six faces, numbered 4, 6, 10, 12, 15, and 24. The dice is thrown twice, and the highest common factor HCF of the two scores is recorded. Draw a sample space diagram to show the possible outcomes. Okay, let me do it. Mm, hmm, this would be um, let me write it down like this is for the first row, and this would be for the second. And then the numbers are 4, 6, 10, 12, 15, and 24. And for this as well, 4, 6, 10, 12, 15, and then 24. Okay. Okay, now let me complete this. Um, we need to have their HCF. The HCF of 4 and 4 is 4. HCF of 4 and 6. The common factors of 4 and 6 are 1 and 2. So highest being 2. So let me write down 2 here. The HCF of 4 and 10 uh, uh, is going to be, the common factors are 1 and 2 only. So the HCF is 2. For 4 and 12, the common factors are 1, 2, and 4. So HCF is 4. For 4 and 15, uh, only 1 is the common factor. So that is the HCF. For 4 and 24, 1, 2, 4, and that's it. So HCF is going to be 4. For similarly, 4 and 6, again, this would be 2, 6 and 6. 6 is going to be the HCF, 10 and 6. Again, that would give me 2 as this was the case. Then for 12 and 6, mm, this is going to be 6. Okay, let me do it like this. 2 3s are, 2 6 are, and then 3 1s are, 3 2s are. So HCF is 6. That's what I've written. Okay, for 15 and 6. This is 3 2s are 6, 3 5s are 15. So this is 3 only. For 24 and 6, this is again 6. How? Like this. 2 3s are, 12s are, and then 3 1s are, 3 4s are. So 2 times 3, that is 6. Similarly, for 4 and 10, the HCF is going to be only 2, and then 6 and 10. Again, this is, would be 2, 10 and 10. This would give me 10, for 12 and 10. This would be 2 only, as 2 5s are 10, 2 6 are 12. So nothing, no more common factors than 1. So HCF is going to be 2 only. For 15 and 10, this is 5, 24, and 10, this is going to be 2. Let me show you 15 and 10. 5, these are 5 twos are, and then 24 and 10. 2 12s are, 2 5s are, and that's it. Okay, for 4 and 12, this would be 4. In the same way, this would be 6. This would be 2. This would be 12, 3, and 12. For 15 and 4, only 1 is a common factor. For this is 3, this is 5, this is 3, this is 15, this is 3. And for this, 24 and 4, 4, 6, this is 2. And the same way, this is 12, this is 3, and 24 and 24, they have the HCF, that is 24. So that is how this part A was to be done, completing the sample space diagram or the probability space diagram. Okay. Now it is part B. Calculate the probability that the HCF is 2. For how many times we are having 2? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And how many are the total sample spaces, outcomes of this, or the elements in this sample space for total? This is 1, 2, 3, 4, 5, 6. So 6 times 6, that is 36. So for part 1, probability that HCF is 2, 10 times out of 36 times. So the probability is going to be 2 5s are 10, 2 18s are 36, 5 by 18. Okay, okay. Then for the second part, the HCF is greater than 2. Greater than 2. Okay, we need to count them, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. So second part, probability that H is greater than 2, that is 24 divided by 36. 4 6 are 24, 4 9s are, and 3 2s are 6, 3 3s are 9. So 2 by 3 is the answer to part 2. Okay, then it is part number 3. The HCF is not 7. From this whole table, all the numbers are not 7. So probability that HCF is not equal to 7 is actually 36 out of 36 times, which is 1. So this is a certain event. The HCF is not 5. For how many times it is 5? Let's calculate that thing. 1, 2, and anything else? Nothing. So probability that HCF is not equal to 5, that is 1 minus probability that HCF is 5. 1 minus 2 by 36 means 1 minus 1 by 18, which is 17 by 18. So that's the answer to part number 4. Okay. The HCF is 3 or 5. Okay. Now these are mutually exclusive events. What are mutually exclusive events? Uh, the events which cannot occur both at the same time. So if the HCF is 3, then HCF will not be equal to 5. And when the HCF is going to be 5, in that case, HCF is not going to be equal to 3. So both of them cannot occur at the same time. So that's why these are mutually exclusive events. So whenever we have got mutually exclusive events, there is a rule that if you need to calculate probability of A or B, if both the events A and B are mutually exclusive, so its probability is given as probability of A plus probability of B. So in this case, I would be calculating probability of 3. Then I will be calculating the probability of H equals to 5. And then we would be adding them. Probability of H equals to 3 or 5. That will be equal to probability of H equals to 3 plus probability of H equals to 5. For how many times this H is 3? Let's calculate that. 3 or 5. No one from here. 1, 2, 3, 4, 5, 6, 7, 8. That's it. So that would directly be equal to 8 by 36. 8 by 36. 4 twos are 8, 4 nines are. So the answer is going to be 2 by 9. But if I do it like this, probability of H equals to 3. 1 times 3, 1, 2, 3, 4, 5, 6. This is 6 times 36 plus this is 2 times out of 36. So that would again give us 8 by 36 like this. So the probability is again, if we do it as a whole or if you do it considering H equals to 3 and 5 to be mutually exclusive events. So again, in both the cases, you get the same answer, 2 by 9. Okay. Now, for the last part, part number 6, probability that the HCF is equal to one of the numbers thrown. Okay, for this, if you see, let me change this color. Let it be yellow. HCF is equal to one of the numbers thrown. Okay, 4 and 6, the we have recorded 4, one of the numbers. Okay, and then 6 and 4, 6 and 6, then 6 and 10, 6 and 12, 3, 6, 15, 6, 24. Okay, then 10, 4, 10, 6, 10, 10, then 10, 12, 10, 15, 10, 24, 12, 4, 12, 6, one of the numbers, 12, 10, 12, 12, one of the numbers, 12, 15, 12, 24, one of the numbers, 15, 4, 15, 6, 15, 10, 15, 12, 15, 15, one of the numbers, and 15, 24, this is 3, so I'm not going to count it. 24, 4, one of the numbers, 24, 6, one of the numbers, 6, 24, 10, 24, 12, one of the numbers, 24, 15, and 24, 24, one of the numbers. So let me count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 14, 15, and then 16. Okay, this one as well, this one as well, because this is 4, 12, 4, 4, 24, and 24. Okay, then what have I missed? This is for all together. This one, because that was 4 and 12. So all together we are having 13 and then plus 3, 16. Okay, 16 out of 36. These are the numbers when HCF is equal to one of the two numbers. Okay, so simplifying them, 4, 4s are 4, 9s are. This is 4 by 9. That's the answer. So that completes question number 4. Okay, this is now question number 5. Two dice are thrown and the result is obtained by adding the two numbers. Two sets of the dice are available. Set A, one dice has 4 faces numbered 1 to 4 and the other 8 faces numbered 1 to 8. Set B, each dice has 6 faces numbered 1 to 6. Copy and complete the sample space diagrams for each set. Okay, let me do it. over here without drawing a separate one for this. 1 plus 1, this is 2. 1 plus 2, 3, 4, 5, 6, 7, 8, and 9. And for this 2 plus 1 is 3. This is 4, 5, 6, 7, 8, 9, and 10. 3 plus 1 is 4. Then 3 plus 2 is 5, 6, 7, 8, 9, 10, 11. And this is 4 plus 1, 5. 4 plus 2, 6. 4 plus 3, 7, 8, 9, 10, 11, and 12. For set B, it would be 1 plus 1, 2, 3, 4, 5, 6, 7. 2 plus 1, that is 3, 4, 5, 6, 7, 8. And then this is going to be 4, 3 plus 2, 5, 6, 7, 8, 9. This is 4 plus 1, 5, then 6, 7, 8, 9, 10. 5 plus 1, that is 6, 7, 8, 9, 10, 11. And then 6 plus 1, 7, 8, 9, 10, 11, and 12. Okay, we are done with part A. Copy and complete the sample space diagrams for each set we have done. Okay, in part B now. In an experiment with one of the sets of dice, the following results were obtained. Dice score and then frequency. For 2, 2 is occurring 15 times. 3 is occurring 25 times. And so on. By comparing the probabilities and relative frequencies, decide which set of dice was used. Okay, you need to see, uh, okay, for 12, the frequency is 14. This one is having the least frequency, so it would be easiest and the fastest for me to calculate. So let's see. Uh, from 2 till 12. If you see from here, adding them up like this. These are 36 results. These one. So these are 8 fours are 32. These are 32 results. Mm. In case of set A, 12 is occurring once and like this. If you see probability of getting 12 from set A, that is going to be 1 by 32. And probability of getting 12 from set B is 1 by 36 because 12 is occurring once out of total 36 chances. Okay, then probability of dice score, that is 2. that is occurring once in both of these sets. For 3, it is 25. So if you just calculate from both of the sets, this is 1, 2 only. So this is 1 and 2 only. Both are alike. For 4, the results are the same almost. 5, 6, and so on. If you see, we are going to have set B, which is showing this probability of the relative frequencies. So we can conclude that this is going to be set B, which is more likely to be having this frequency diagram of. So the answer to this part B is set B. And there is another way in which we can try to find out the result, which is that set B is more likely to have this frequency table of, okay, what's that? Let's calculate the sum of the frequencies from this table. This is, let me calculate it, 15 plus 25 plus 44 plus 54 plus 68 plus 87 plus 66 plus 54 plus 43 plus 30 plus 14. This is 500. If you compare for mm, different probabilities, starting from probability of getting a 3, from this table, the probability is 25 divided by 500, which is 0.05. What is the probability of getting a 3 from set A? That is 2 divided by 32, which is 1 by 16. So that would be 0.0625. What is the probability of getting a 3 from set B? That is again 2 times, but out of 36, because this is 6 and this is 6. So 6 times 6, that is 36. So total possible outcomes in this case is 36, and in this case it is 32, because like this we are having 8, and like this we are having 4. So 8 fours are 32. Okay, so this is 2 divided by 36, which is 0.055. So this is more closer to uh, the probability of 3 given in the table. So in the same way, we can do it for any other number. Okay, let me do it for 4 once again, exactly in the same pattern. Probability of getting a 4 from the table. This is 44 by 500, which is 0.088. So probability of getting 4 from set A, that is 1, 2, 3. 3 by 32, which is 0.09. And probability of getting 4 from set B. Let me calculate it. That is also 4, 1, 2, 3. 3 divided by 36, which is 0.3 by 36, which is 0.083. So this one is more closer to this 0.83 and 0.88. But if you compare or take the difference, in this case, the difference between 0.88 and 0.09, that was 0.08. The difference between them is minor, but that is 0.002. And the difference between them is obviously more as compared to the previous difference. So we can say that this data is more likely to be for set B as compared to set A, but set A on the same time is not that much far from the results. So you can say that set B is the one that is showing the results closer to this frequency table, but set A is also so we were saying that this set, this frequency table resembles or is more closer to set B, but set A is also not an appropriate option. That means in some cases, this frequency table resembles more closer to set B, but for set A, it is not far from that frequency table as well. So this is how we need to answer that question.